Hey everybody, so we're going to do a demo today of what is called a wet cell. In other words, this is just a battery that we're making, but we're making it using chemicals. So there's a document that I've put on Google Classroom for you to follow along with, and hopefully you've watched the video on identifying and writing out manipulated, responding, and controlled variables. First of all, I'm going to just explain what we're doing here, and you can follow along in that booklet to just kind of write some things down as we get to those sections. So first of all, the problem here is actually twofold. We're actually going to be doing two experiments within the one demo that I'm doing today. The first experiment that we're going to be doing is we want to test which electrode combination yields the highest voltage. And so you might ask, well, what is an electrode? And this is something that you need to have in your notes. These are just conductors that are part of a battery that will allow an electrical current to flow through them. And they're usually made of metals, sometimes non-metals, like this one is carbon, and that's a non-metal. But they're just places where electrons can flow through and complete a circuit. The other experiment that we're going to be testing, or problem we're going to be testing, is which electrolyte is going to yield the highest voltage. And so we have two electrolyte solutions here that we're going to test. We have a salt solution and we have an acid solution. So what I want you to do is I want you to pause the video, and in the booklet there's a place where you can write out your two hypotheses for the two experiments that I'm going to demo for you. So the first hypothesis that you're going to write down is which two electrodes together do you think will yield the highest voltage? And then which electrolyte do you think will yield the highest voltage? Both of these electrolytes are the same concentration, but they're made of different solutions. Once you've done that, then what you can do is you can go to your materials list in your booklet as well, and there's a place there where you can list out all the various materials that we have in the experiment. So I'll run through those with you, and again, if you need to pause the video to keep up, that's okay. So we've got two 100 milliliter beakers here. We also have two electrolyte solutions, one acid solution, one salt solution. We've got five different electrodes. We've got zinc, carbon, tin, aluminum, and copper. Those will be the ones that we'll be testing. We also have a multimeter here in order for us to measure the voltage. So what I'm going to do now is I'm going to demo this for you, and as I do this, there's a section in your booklet where you can write down your procedure. So a procedure is a step-by-step set of instructions that if you were to give it to someone that has never completed this experiment before, that they'd be able to replicate the experiment with relative ease. So I know the tendency here is to be really concise with what you're writing and kind of write down stuff that you know happened. And when we do that, sometimes what we do is we leave out important information for people that, if they were to try and replicate our experiment, wouldn't know what was going on because we didn't include enough detail. So when you're writing your procedure, you need to really make sure that you are writing it for someone that doesn't know what is happening and has never done this experiment before. Also, when you're doing the procedure, again, like I said, it's a step-by-step set of instructions. So you're going to do sort of step one and then write out what you did, or write out what I did. And then step two, what's the next thing that person's going to do? And then step three, here's the next thing that you would do. And so it's not a paragraph or a description per se, or like a mini story. It's really just a set of step-by-step instructions where someone can follow them quite easily and complete the experiment without having to ask any questions. So make sure that your procedure is very detailed. If you flip the page over in your booklet, you'll notice that there's a chart that I've given. Now there's two charts here. One chart is for you to record voltages for the acid solution. That's the first table. And the second table or chart is for you to record the voltages for the salt solution. So one's for the acid, one's for the salt. I don't care which one you put where. I'm going to start with the salt solution, so I guess you could start with the salt solution at the top and the acid solution on the bottom. But it's up to you, it doesn't really matter. As long as each table is labeled appropriately, that's fine. In the table, you'll see that you can Also make sure that when you're writing the electrode combination or writing the voltage down for each electrode combination that you have the correct electrode combination here. I've blanked out places in this table where you won't be writing numbers, so it's just in the white spaces provided. The first electrode combination that I'm going to do is zinc with carbon, so then that will go in that first box right there that you can see me pointing out with my finger. Might be a little hard to see, but if you're following along in your booklet, it should be fine. So here I go. I'm just going to put these electrodes in the solution. I'll call out what the number is. You guys can write that down in your booklet, and then I'll show you what we're going to do with that information afterwards. So this is zinc with carbon. You can find that in your booklet. Make sure that you're writing this number down in the correct spot. And this first reading is 768. Oops. The next one is zinc and tin. And this is 417. These units are in units of millivolts. So little m, capital V. Every time that you write these numbers down in your chart, you need to make sure that you're sticking the units after the number. This is zinc and aluminum. This number was 298. And this is zinc and copper. This one was 900 millivolts. Okay, so I'm done with the zinc electrode. I'm now going to do carbon with tin. Carbon with tin. And my number here is 163. The next one is carbon and aluminum. This carbon electrode is being difficult. This one is 485. And the last one with carbon is copper, and copper yields 33 millivolts, just 33. Okay, done with the carbon. Now I'm going to do zinc with aluminum. Sorry, this is tin and aluminum. This is 294. And this is tin with copper. This is 199. So I'm now done with the tin electrode. I'm going to do now aluminum with copper. This is 512. I'm done with the aluminum here. The last one that I'm going to do, because this is information that you need to know, is what happens when we do a wet cell battery where we have two electrodes of the same conductor. So both here are going to be copper. Now this is the same result whether they're both copper or both zinc or both tin, it doesn't really matter. So we'll just do this one. This is copper and copper in the salt solution, and this is 0 millivolts. So I'm going to get the next part set up here with the acid solution, and we'll redo all those combinations, and you can write that down in the next chart. Okay, so here's my next setup. I've got the acid solution ready to go, and the first electrodes that are in here is, again, zinc and carbon. So zinc and carbon yields 745. cords are a little bit in the way here. Next combination is going to be zinc and tin. Zinc and tin is 489. Zinc and aluminum, 291. Zinc and copper, 866. Zinc is finished. Carbon and tin. $297. Carbon and aluminum, $541. Carbon and copper, 50. Next one is tin and aluminum, 222. Tin and copper, 357. Tin is finished. Aluminum and copper, 570. And lastly, the 2 copper electrodes, again, that yields 0 millivolts. Now, something else that you've noticed maybe as I've been doing this is I've always made sure that the electrodes are not touching each other. And what also happens is when the electrodes touch each other, the reading for the voltage goes to 0 as well. So that's something that you should make note of in your notes somewhere, is that we get 0 readings when we use 2 electrodes of the same conductor. And also we get a 0 reading if the electrodes are touching in any way while they're in the solution. All right, guys, so this next video is just showing you a little bit on what you're supposed to do when you're asked to make a graph. So we've done graphs a little bit already, but just to reiterate and to remind you of a few important concepts and a few important things that you need to pay attention to, and then also just some things that are tailored to this particular assignment. So first of all, remember that when we do graphs, we need to put our manipulated variable along the x-axis and our responding variable along the y-axis. So you can see that I've done that. And make sure that those axes are labeled. If they have units like voltage, then make sure you put the units in brackets as well. This graph is going to be a double bar graph, and it's because for each electrode combination that we've done, so let's say this one was aluminum and copper. For each electrode combination that we tested, we also tested that electrode combination in 2 different electrolytes. So you can see over here in my legend, I've got some boxes and rectangles that are sort of filled in with the lines. That's going to represent my acid solution electrolyte. And then the ones that are white are just my salt solution electrolyte. And so for each electrode combination that we tested, I'm going to have that along the x-axis. And then I'm going to have 2 bars for each of those electrode combinations, showing their voltage reading on the graph for each of those electrode combinations as it corresponds to what solution they were tested in. And then also down here at the bottom, underneath of the graph, in science it's kind of weird, but this is how we do it. When we title graphs and figures, those titles always go underneath of those graphs and figures. So we're going to put the title down here. Make sure that your title is very descriptive and you don't leave any details out, and we've practiced that already. in terms of, you know, what was done, what are the manipulated variables, responding variables, make sure that those get put in to the title for sure, and what exactly it was that we were testing. And then finally, just make sure that when you're doing the graph that you do it with a ruler if you're doing it on paper. If you are choosing to do your graph at home on a computer, then that's totally fine as well. You can most definitely do this in a program like Microsoft Excel or possibly even Google Sheets. And so if you found a different way that you'd like to make the graph that just makes it look nice and neat and cool, then that's great. If you are doing it on paper, make sure that your bars are colored an appropriate color. Don't do just the lines like I did here. Just a demo, so I'm just showing you how to distinguish the two from each other. But make sure it does have color and that you do use a ruler. You'll also notice in the booklet that there are some conclusion questions at the end. Don't forget to answer those and write as much detail as you can for those questions. And when it's ready to be submitted, go ahead and submit.